Hello and welcome to today's class. We'll be talking about Cauchy-Riemann's equation, right? To be precise, we'll be treating the GT 210 test solution in engineering mathematics. Question 1b. We are told that solve the value of C1 and C2 such that function of z, f of z is given to be this. Is analytic. That's question 1.
Exactly.
Question 2 says what?
And also
Find the derivative of z, that is f prime of z. Okay, me saying this question now, with this question, question 1 says I should determine if this function is analytic, right? Then 2, find the derivative of what? Z of the function. But observe, from what I know in differentiation, I'm given this function, I can differentiate, right? But I'm having C1 and C2 to be my constant. So that's why the question was saying that solve the value of C1 and C2. By the time I know the value of C1 and C2, I'm going to substitute. By the time I substitute, I will check if the function is analytic or not. Then I'm done with question 1. Then question 2, I'll be able to find the derivative. But before going through all this process, before solving this, what does Cauchy-Riemann equation means? When we say Cauchy-Riemann, what does it mean? Right? In Cauchy-Riemann, what we are employing or what we are using is complex number. Our function, we will be given a function in this case, but our function is expressed in terms of complex number. Right? Let's say we are given a function of z, and this function has to be expressed in complex number.
Yeah.
U plus IV. I'm familiar to this. Where U is the real part of z and V is the imaginary part of z. But in this case, I can still write this function as U open bracket xy plus I open bracket V, plus IV open bracket xy. What I'm saying is that this function is still the same thing as this. Meaning U, generally, in Cauchy-Riemann equation, I said the first thing is what? My function is expressed in terms of complex number, which is this, right? Number 2, I can still rewrite this function as this. Why? Because U, which is the real part, is a function of x and y.
Yes.
YV also is a function of x and y. So in my question given, I'm expecting real part of z and imaginary part of z. But the real part of z will be in what? Function of x and y. Then imaginary part of z will also be in what? Will also be a function of x and y. That's the interpretation here. Now back to this question. Comparing the given function to this, are they correlating? Why? Because the given question, I'm giving f of z to be this. The first thing is to compare this given equation to Cauchy-Riemann equation, which is what? Complex number. By doing that, it means this is from Cauchy-Riemann equation, right? This is from Cauchy-Riemann equation. From the given equation, I'm having f of z is equals to what? X squared minus c1 c2 minus 2xy plus I open bracket c2 x2 minus y squared plus 2xy. This is from the given question, and this is from Cauchy-Riemann's equation. This is what I know from Cauchy-Riemann's equation. Now compare 1 and 2. What will be my u, what will be my v? Comparing 1 and 2, it means that u is equals to x squared minus c1 y squared minus 2xy, right?
Yes.
Then v is equals to c2 x squared minus y squared plus 2xy. So this is what I'm working with. And from here, coming back to this place, we said u is a function of what? X and y. And we have x and y present here, right? We also said v is a function of x and y. Similarly, you also have a function of x and y.
Yes.
Are you with me? So these are the first two things we need to know under Cauchy-Riemann's equation. Then, but in Cauchy-Riemann equation, let me just say this. What you are going to is to check if that given function is analytic or not. Are you with me? And to check, there are these conditions you need to put into consideration. right? What are the conditions? Partial du over partial dx plus is equals to partial dv over partial dy. This is the first condition.
Yes.
Are you with me?
Yes.
Then the second condition is what?
Partial du over partial dy.
Partial du is equals to the partial derivative of v
over partial derivative
minus partial derivative of v divided by partial derivative of x. From Cauchy-Riemann's equation now, we've said 4 things, right? The first thing is that my function will be expressed in complex form, having my real number and imaginary number. This is it. And the real part in this case is what? U. And the imaginary part in this case is what? V. Right? In complex number, let's apply the idea of complex number here. How do I know that U is my real part? And how do I know that V is my imaginary part? Just know that in complex number, when Z or if Z is equals to X plus I Y, this is a complex number. Why is it a complex number? It is a combination of real number and imaginary number. Then how do I identify my imaginary number? The one I'm having I with.
Yes.
This I is imaginary number. So that's what we did here. We related this and this together. We are now saying this is my real number and this is my imaginary number. But real number has two functions, which is x and y. Similarly, v2 is having two functions, x and y. So that's it. Then number 3 is that to test this given function under Cauchy-Riemann, this condition, this number 1 condition must be satisfied. Meaning partial derivative of u with respect to x must be equal to the partial derivative of v with respect to y. That's first one. Partial derivative of u with respect to y must be equal to negative partial derivative of v with respect to x. Hence, if these two conditions are satisfied, it means the given function in that case is analytic function. Are we together? So that's it. That's all we need to know under Cauchy-Riemann's equation. Now back to this question. Please, you can take note of this first condition and second condition, because that's what we are going to use. Back to the given question. I'm giving my function to be this, and from this function I've identified which one is my u and I've identified which one is my what? V, right? I want to check if the given function is analytic or not. What's the first condition? It says that the u, partial derivative of u with respect to what? Must be equals to
partial derivative of
v with respect to
partial derivative of
y. This is the first condition. Then the second one is partial derivative of what?
Partial derivative of u.
Of u.
Over partial derivative of y.
To
negative partial derivative of v. Over partial derivative of x.
And I know that u is equals to, what's the value of u here? Or what's the expression for u? X squared minus c1 y squared minus 2xy. What I just need to do here is to differentiate u in respect to x and differentiate u in respect to y. The only way you can do this is to recall your partial derivative. In partial derivative, first of all, why am I using partial derivative here? Let's start from that place. Why am I using partial derivative here? I'm using partial derivative because u is a function of x and y. You know, let's say, consider this. When u is equals to x, call this case 1. When case 2, when u is equals to y, and case 3, when u is equals to xy. 1, 2, and 3, they are different. By the time you differentiate, you are going to get the u over the x here. By the time you differentiate, you are going to get the u over the y here. But in this case, by the time you differentiate, you will be having the u over the x and the u over the y, which are referred to as partial derivative of u with respect to x and partial derivative of u with respect to y. So what we are saying is that since we have two functions present in a given equation, then it means partial differentiation, partial derivative. Same approach here. Since we know that u is this, we want to differentiate. I'm having two functions which are x and y. First thing to come to my mind is what? Partial derivative. So partial derivative of u with respect to x is what? When you are doing partial derivative, your interest should be your x function. Differentiate your x function. By the time you differentiate your x function, take every other function as constant. They are not included, 0. You understand? For the first one, I'm seeing x squared. Then x squared, by the time I differentiate x squared, what will I get? That will be what? 2x, right? Minus, moving on, I'm seeing c1 and y squared, and I'm doing derivative of u with respect to s. So I'm taking this as a constant, that is minus 0. Minus, I'm having 2xy, but I'm differentiating with respect to x. Now, differentiate x here. What do we have? We have 2xy. We are having 2xy. Differentiate x. What will be the derivative of x? 1. Derivative of x is 1. So you are now saying that 1 times 2 times y, that was 2y. Similarly, what if we have 2xy? I want to get, call this u equals to this, and you are doing partial derivative of u with respect to y. You know what it means, Abi? Differentiate, how do you get 2x? You differentiated y and you got 1. You are now saying that that 1 times 2x, and which is 2x. So that's the idea of partial derivative. Okay, from here, by the time you differentiate this, you have 2y, which implies that 2x minus 2y, right? And this is just partial derivative of u with respect to x. Now, the next one, let's do the partial derivative of u with respect to y. And that will be equals to what? This is the given function. I'm having x squared. There's no function of y attached to this. I'm taking it as 0, constant, 0. Minus, I'm having c1 and y2. There's a function of y attached to that c. That is, I can differentiate. Differentiate y squared. What do you have? 2y. 2y times c1. 2c1y. Or you say 2y c1. Anyhow you put it, it is multiplication. So let's go with 2y c1. Then let's differentiate this with respect to y. Differentiate y. 1. 1 times minus 2x minus 2x. So it implies that the partial derivative of u with respect to y is equals to minus 2y c1 minus 2x. The given question, it was positive and not negative. So let's trace that. So u here will be positive. You can change that. That's positive and not negative. Change it. So from here to we have positive and not negative. Okay, so this is positive. So this is still correct. Then from here, this is positive. By the time we are doing partial derivative of u with respect to y, meaning du over dy. Differentiate 2y. Differentiate y squared. That's 2y times this. This is it. Minus this minus. Differentiate y. 1. 1 times 2x. 2x. Which implies that 2y c1 minus 2x. And that was what? Partial derivative of u with respect to what? Y. Then you are done with the derivative of u both in respect to y and in respect to x. Now, let's take the next one. From here, my v is a function from the given question or from the given function. My v is equals to c2 x squared, right? Minus y squared plus 2xy. Abi? Now from here, same idea. I'm differentiating v with respect to x. I'm differentiating v with respect to y, meaning partial derivative. Abi? Now, the partial derivative of v with respect to x, that will now be what? Differentiate x squared. That was what? 2x. 2x times this. 2xc2. Taking this as constant, minus 0. Differentiate this, plus 2y. For the last one, the v over dy, let's differentiate this. Partial derivative of v with respect to y, that's minus 2y then this is plus 2x, right? Let's bring our respective partial derivative out. Du over the x. My du over the x is what? Partial derivative of u with respect to x. 2x minus 2y. Partial derivative of u with respect to y is equals to what? 2y. 2y c1 minus 2x. Derivative of v with respect to x, and that's what? From here, what do we have? That's 2x c2 minus 0, which is the same thing as saying plus 2y, right? Then the last one, partial derivative of v with respect to y is equals to minus 2y plus 2x, right? These are the derivatives of the real part and the imaginary part. Now let's put this derivative in the condition of an analytic function when it comes to Cauchy-Riemann's equation, right? The first condition states that for your function to be analytic, it means the partial derivative of u with respect to x is equal to the partial derivative of v with respect to y. Now come back to this place. What is the partial derivative of u with respect to x? 2x for the first condition. 2x minus 2y, that is the partial derivative of u with respect to x. This is it. Equating it to what? The partial derivative of v with respect to y. What do we have here? Minus 2y plus 2x, right? Which is still the same thing as writing 2x minus 2y is equals to 2x minus 2y. Are we there? This is the first condition. For the second condition states that the derivative of u with respect to y is equals to negative derivative of v with respect to x. Now come back to this place. What is your partial derivative of u with respect to y?
2y.
With u with respect to y. This is it. Partial derivative of u with respect to y. This is the value. As 2y c1 minus 2x, equating it to negative open bracket partial derivative of v with respect to x. Where is it here?
2x.
Partial derivative of v with respect to x, and this is the expression for it. 2x c what? c2 plus 2y. Open up your bracket. 2y c1 minus 2x is equals to minus 2x c2 minus 2y. Right? Then from here, we said that the partial derivative of u with respect to y must be equal to the negative partial derivative of v with respect to x. Abi, let's compare the left hand side of the equation and the right hand side of the equation. Are they equal? No, they are not equal. We are having 2y c1, the function of y in the left hand side here is taking positive, while the function of y in the right hand side is having negative. Are you with me? In the left hand side, the function of x is having negative, while the function of x in the right hand side is also having negative, meaning the x function, they are equal, but the y function, they are not equal. We are having positive and we are having negative. Indirectly, this question or this equation, there's something I need to do, but this is it. What was the question? The question says that solve for the values of c1 and c2. Solve for the value of c1 and c2 which satisfy the Cauchy-Riemann's equation for the given function. So what it means is that you are going to you are going to collect like term, bring the factor of x together while the factor of y together. Then by the time we do that, we will now ask ourselves again, are they equal? Now let's do that. Meaning 2y c1, I'm bringing the function of y to be in the left hand side. I'm having this there before. This is it. Then this one is come here. Plus 2y equals to minus 2x c2, then this one will go there, plus 2x, right? And it's still the same thing as writing 2c1 plus 2y equals to, expressing the positive term first, 2x minus 2x c2, right? Let's stop. What we need to do, observe, you can factorize. From the left hand side, you can factorize 2y. 2y, open bracket, open bracket c1, right? Plus 1 equals to, you can also factorize 2x at the right hand side. 1 minus what? 1 minus c2. This time this, you still get this. This time this, you still get this. This time this, you have this. This time this, you have this. We want to estimate the value of c1 and c2. Since the question initially told us to find c1 and c2, right? From here, 2 can cancel this, right? 2 cancel here. Then we have c open bracket c1 plus 1 is equals to 1 minus c2, sorry, x equals to x open bracket this. Then from here, I need to get c1 and I need to get c2 from the question. How do I get that? I can equate from the left hand side. From the left hand side, I can equate c1 plus 1 equals 0. Then if I equate that, it means that c1 is equals to what? Minus 1. From the left hand side, I'm equating c1 plus 1 to be 0. Then make c1 the formula. 1 will come here, minus 1. Now, from the right hand side, if I'm equating c1 plus 1 to be equal to 0 in the left hand side, then what should I equate in the right hand side? 1 minus c2 equals 0. From there, make c2 the result of the formula. It means 1 equals to minus c2 go to the other side equals c2, which implies that c2 equals to 1. Hence, also therefore, the value of c1 is calculated to be minus 1 and the value of c2 is calculated to be 1. Do you have any question? Then how do I know if I'm correct with the value of c1 and if I'm correct with the value of c2? From algebra, left hand side must be equals to what? Right hand side. Since I didn't know c1 to be minus 1, by the time we put it here, and I didn't know c2 to be 1, by the time I put it here and multiply, it must be having the same thing. We've gotten c1 and c2. The first question, we are asked to solve the value of c1 and c2, which is c1 is minus 1 and c2 is equals to what? 1. But the first question says, determine if the given function is what? Analytic. Since I didn't know the value of v1, since I didn't know the value of c1 and c2, I can substitute c1 and c2 in the given function. Are we together? Meaning, the given function f of z, that will be equals to x squared. What was my c1? My c1 is negative 1. So it will now be plus, open bracket, minus 1 times y squared minus 2xy. X squared, this is still x squared.
Yeah.
Plus, this is still plus. C, we've calculated c to be minus 1. That's why we substituted it here. Y squared, this is still it. Minus, this is minus 2x and y. Meaning, I'm having, by the time you multiply this, you're having x squared minus y squared minus 2xy. Are we together? So let me rub off this. So I'm saying that f of x is equals to this, and we know how we got this. F of z is equals to this, plus I open bracket. Similarly, c2 is what? 1. 1 times x squared is still x squared minus y square plus 2xy. Now you can now attempt question 1. Question 1 says check if the function is analytic. Question 2, the derivative of z. And we know that f of z can be written as u plus iv, meaning u is equals to, from here u will be equals to what? X square minus y square minus 2xy. Then v is equals to x square minus y square plus 2xy. The first question, now we found C1 and C2. By the time we get the value of C1 and C2, we substituted those values inside the given question. Then this is it here. By the time we substitute, this is, you can now rewrite the given function as this. Now we want to attempt question 1. Is the function analytic? That's question 1. And before you can say a function is analytic under Cauchy-Riemann equation, what does it mean? Partial du over partial dx is equals to what? Partial dv over partial dy. This is the first condition. The second condition is partial du dy is equals to minus partial dv over partial dx. From here, from this place, du, okay, let me solve it here. If v is equals to x square minus y square minus 2xy, du over dx, partial du over dx will be equals to, that's 2x minus 2 minus 0 minus 2y, yeah. Then from here, partial du over dy, that's equals to minus 2y minus 2y. Is it supposed to be minus or plus? Okay, let's continue. Minus 2s minus 2, no, partial du over dy, 2 exactly 2x, right? Then if v is a function, or let me do that one here. If v is a function of this, then partial dv over dx, that will be what? 2x plus 2y. Derivative of v with respect to x. This is 2x. Taking this as constant, this is 2y. Partial dv of what now? Y. That will now be equals to minus 2y plus 2x. Any question? No question. Okay, let's substitute for this first condition. What's the u over ds from what we've solved? 2x minus 2y equals to partial dv over dy. Partial dv over dy. That's minus 2y plus 2x, which implies 2x minus 2y is equals to 2x minus 2y. We are arranging the positive term first.
Yes.
Now, since from here, since this partial derivative of u over x is equals to partial derivative of u over y, what does it mean? The given function is what? Analytic. This is just for the first one. What about the second one? Let's confirm. What's the u dy?
That's minus 2y
minus 2x equals to
negative
negative partial derivative of dv and x. And what's dv and x? That's what? 2x plus 2y. Factorize this. This implies, by the time you factor out the minus, right? Minus is common now. So you can bring minus out. 2x plus 2y equals to minus 2x plus 2y. Second condition is satisfied. Meaning, since first condition and second condition is satisfied, hence, you cannot write, hence, the given function is an analytic function, is analytic, then that's all. You answer that question. That's for number 1. This is just from our figure 1. For my figure 2, then question 2 says that find the derivative of z, right? We said earlier that function of z is in form of complex number, which is u plus iv, which is still the same thing as u open bracket xy plus I open bracket ixy, right? So how do you get the derivative? The derivative of z. The derivative of z, the first one is partial derivative of u with respect to x plus I partial derivative of v with respect to x. You are differentiating u with respect to x. You are differentiating v with respect to x. The derivative of u with respect to x. 2x minus 2y. 2x minus 2y, right? Plus this plus I. What the derivative of v, the partial derivative of v with respect to x? 2x plus 2y. So this is your derivative, but you can factorize. Since 2 is common, I can factorize 2 from everything. X minus y plus I open bracket x plus y. Then this is my answer. Alright, from the given question, question 1 says that is the function analytic? We've solved that, right? We've known if the function is analytic or not by satisfying the 2 conditions under Cauchy-Riemann's equation. Then this, we are told to find the derivative of x, f of prime, and this is my answer. So this is what we need to know under Cauchy-Riemann's equation. Let's take another example. The question says what? Given the complex function, we are given a complex function. Why am I given a complex function? Because my function under Cauchy-Riemann's equation must be in form of what? Complex number, right? Now, the question says, given a complex function, and what is the complex function? Function of z equals to u open bracket x comma y. Okay. All right. You are familiar with this. Where z x plus iy and function of z is equals to z squared.
Verify that the function satisfies the Cauchy-Riemann equation.
Okay, we have to verify that the function satisfies Cauchy-Riemann's equation. Now, what was the function we have to verify in this case? That's what? Fz, which is what? Z squared. We are given this function. You are familiar with this. You are also familiar with this. Okay? You are given this. You are familiar with this. Then we are given z to be this. Then the function we are asked to verify is z squared. But I'm already told that z is what? X plus iy. Meaning this function f of z is the same thing as x plus iy all squared. So this is the function I want to verify if it satisfies Cauchy-Riemann's equation. All I need to do here is to recall what must be the condition for your function to satisfy Cauchy-Riemann's equation. The first condition is what? And if it satisfies Cauchy-Riemann's equation, it means the function is analytic. So what's the first condition? Partial derivative of u over partial derivative of x is equal to partial derivative of v over partial derivative of y. This is the condition 1. Condition 2, partial derivative of u over partial derivative of y minus partial derivative of v over partial derivative of x. So if these two conditions are satisfied, it means this given function is verified under Cauchy-Riemann's equation. In other words, they are saying that this function is analytic. But let's ask ourselves, I need to work with this condition. I need to know my u and I need to know my v. Me saying u, the real part of this function. Me saying v, the imaginary part of this function. Solving for f of x equals to x plus iy squared. It means x plus iy all into bracket x plus iy. What you just need to do is do your simplification. This time this, open bracket. This time this will give me x squared. This time this will give me plus ixy. This time this will give us plus ixy, right? This time this will give us plus I square y square. Then which is equals to x square plus 2, we have I, plus I to xy plus I square y square. But recall, in complex number, I square is what? Minus 1. Recall, from complex number, I square is what? Minus 1. So anywhere I see I square, I'm going to substitute minus 1 here. Okay, why am I saying I square is minus 1? Let's see. From complex number, I know that I is equal to square root of minus 1. By the time we take square root to both sides, you are saying that I raised to the power of 2 is equals to square root of minus 1 raised to the power of 2. Square root cancel this. Then you have I square is equal to minus 1. So that's where the idea is coming from. What if you have I raised to the power of 4? It's the same thing as saying I raised to the power of 2 times I raised to the power of 2. That is minus 1 times minus 1, which is equals to what? 1. And so on and so forth. But here, we only need I squared. And we know that I squared was minus 1. Meaning, anywhere I see I squared, I'm going to substitute the value of I squared to what? Minus 1. So let's do that. I'm saying that f of z is equals to x squared. Nothing is changing aside from I squared. Plus what? I to xy minus y squared. We substituted I squared to be minus 1. As we know, under Cauchy-Riemann's equation, we are going to have our real part and our imaginary part. But this question is this that led me to this. I have to separate the real part from the original part. So the only way I can do that, that's x squared minus y squared plus I 2xy. This and this can come together. Then this should stand on its own. The next thing to do from here, which one is your u and which one is your v? Relating these to Cauchy-Riemann's complex form, it means u is what? What will be my u? U is equals to x squared minus y squared, and v is equals to 2xy. And v is equals to what? 2xy. But the question wants to know if this function satisfies or it verifies Cauchy-Riemann's equation. And before it can verify Cauchy-Riemann's equation, these two conditions must be satisfied or must be met, right? Now, let's get, since I know that I need the derivative of u with respect to x, derivative of u with respect to y, and similarly to this derivative, we can estimate it here, right? For the first one, okay, let's do that here. From u equals to this, the derivative of u with respect to x will be equals to 2x. This, you are taking this as constant. The derivative of u with respect to y will be equals to minus 2y. Then for v, since we know that my v is equals to what? 2x y. Derivative of v with respect to x will be equals to what? 2y. And the derivative of v with respect to y will be equals to what? 2x. What do I need to do from here?
Verify.
We should verify.
Yes.
Then how do I verify? This must be equal to this.
Exactly.
Now, what's the value of derivative of u with respect to x from what I've done so far?
Yes.
We are verifying it here. Let me use a blue marker to do that. So, for the first condition, 2x, derivative of u with respect to x, this is it, 2x, must be equals to the derivative of u with respect to y, 2x.
Yes.
From here. That's the first condition. Number 2, derivative of u with respect to y is what? Minus 2y must be equals to the negative derivative of v with respect to x. So we are saying negative. What is the derivative of v with respect to x? 2y. What can you conclude from here?
Hence the
S,
function is analytic. Function of z is analytic.
the function given, which is z squared, verify the Cauchy-Riemann's equation. Cauchy-Riemann's equation. In other words, it means the function is analytic. Then you are done with that question. So that's it when we say Cauchy-Riemann's equation. It all depends on you being able to differentiate. When I say differentiate, your partial derivative, just know that you are differentiating with respect to your own interest, then you are taking the other function as a constant, which should be 0. Alright, in the subsequent video, the solution to other questions will be solved here. Do well to like, subscribe, comment, and share.